Hi everyone, today we're going to talk about even and odd polynomials. Now, you're going to hear the word polynomials a lot in this semester because it is one of the main concepts in AP Pre-Calculus. Now, talking about even functions and odd functions or even and odd polynomials, you have to know two main sentences, okay? Now, you have to know that even functions are symmetrical over the y-axis. Now, I am going to investigate in this sentence or do an investigation for the sentence and explain more and more what does the word symmetrical over the y-axis. And you have to know that odd functions are symmetrical over the x-axis. So again, even functions are symmetrical over the y-axis. Odd functions are symmetrical over the x-axis. Now, to understand what does that means, the word symmetric means like you can handle or you can deal with the y-axis like the mirror. I mean, look at the function here. From this side, you are going to see the exact function on the left side. So you can deal with the y-axis like what? Like mirror, okay? So we can deal with the y-axis like what? Like mirror. We have the same shape. From right, the same shape from left. Now, in other words, take any part from the function or any special part from the function. I'll take this cavity here. This is in the first quadrant, right? We have the same cavity exactly in the second quadrant directs. So if you have the same shapes in two consecutive quadrants, so if the first shape was in the quadrant 1, the second exact shape must be in the second quadrant. That means you are talking about an even function, okay? Now look at the second function here. You can assume that the y-axis is the mirror. If the y-axis is a mirror, that means you are dealing with what? With an even function, okay? Direct. Or you can handle it as in the second method. Take a special shape here. You have this in the fourth shape, right? Okay? Now, where is the second special shape or what is the special shape, exact special shape? Where is that? It's right here in the third quadrant. We're talking about two consecutive quadrants. That means you are dealing with a what? With an even function, okay? Or you can say, since we can deal with the y-axis as a mirror, that means the function is symmetrical over the y-axis, which means you're dealing with what? With an even function, okay? Now, look at the last one here. Okay, take a special shape. You can take this one, which is in the quadrant 1. What is the second exact shape? It's this one, which is in quadrant 2. We have the same exact shapes in two consecutive quadrants. Or you can say that the y-axis, we can handle it or we can deal with it like mirror. That means you are dealing with what? With an even function. Okay, we have another special shapes. You can take this shape, which is in the fourth quadrant, and this shape, or this exact shape, as in the third quadrant, right? So that means you are dealing with what? With an even functions, okay? Now, this is the first rule that you have, or we can use it to distinguish between even and odd function using graphs, okay? Now, but here's the thing. We have a special rule for even function also. F of x equals f of negative x, that means you are dealing with what? With an even function. Now, let's try to apply or to use this rule. Assuming that we have this function as f of x equal x squared. Now, the graph of f of x equal x squared looks like this. This is the graph of it. It's that U-shape which starting from the origin. Okay? This is the y-axis. And this is the x-axis. Now, in this graph, you can see that you can deal with the y-axis as a mirror, so it is an even function direct, okay? It's an even function direct. But if we need to use, or if we want to use this rule to prove that you are dealing with an even function, what is f of x? It's x squared. Now, what is f of negative x? What is f of x? F of negative x means? It means replace x with negative x. It's minus x squared, right? And that gives you what? Because of the exponential, you have an odd number in the exponential. That means the negative sign will what? Will eliminate itself. I mean, what is negative x times negative x? That gives you x squared again. So that means f of minus x equals f of x. So that means you are dealing with what? With an even function also. All right? Now we have another method if you did not get this one. Take f of 1 and f of minus 1. If they both are the same, that means you are dealing with an even function. What is f of 1? It's 1 squared, right? And that gives you 1. Take f of minus 1. This is minus 1 squared, which means negative 1 times negative 1. That gives you also 1. Since f of 1 equals f of minus 1, that means you are dealing with what? With an even function.